Hello everyone, Assalamu alaikum. Welcome back for another video in the series. In this video, let me now show you a brief code example illustrating the concept of cross entropy in code using PyTorch. So I have prepared a notebook that we will follow along. So we execute this. Here I have a function for implementing the OneHot encoding in PyTorch. It looks like a little bit arbitrary with this scatter function. I don't really need to get over this because I think there is no other context where I think this scatter function is really that useful. So you don't have to really memorize how this works. If you ever need a one hot encoding yourself, you can just copy and paste this function. As you can see, it will do it for you. And also when we do train a softmax regression model later, I will show you also a code example for that, and the same for multi-layer perceptrons and so forth. The loss functions in PyTorch, they already do the one-hot encoding for you. So you actually never have to worry about that yourself. But if you ever have to do it yourself, you can just copy and paste this function. So this is just how it works. This is exactly the same example that I showed you on the slides where we have the class labels 0, 1, 2, and 2. And I have a total number of class labels here. This is the highest class label or the number of classes, the same thing. So here we have three possible class labels, 0, 1, and 2. Also note that your class labels should always start with 0. So in this case, what we get back is for the four training examples here, 4 rows, and each has an indicator whether it's this class, the one in is denoting the class, and 0 is it's just a placeholder. So for the first training example, this represents class 0, class 1, class 2, and class 2 again. Then this is actually the net inputs. So this is a matrix of net inputs. I created them just arbitrarily. So each row is again for each training example. We have 4 training examples here. So we have 4 rows, and this is how our net inputs might look like. And then now we have to apply this softmax here, and then we get these activations. Yes, just for reference, how the softmax function looks like. Here's a code implementation of the softmax function. Um, so you actually shouldn't use your own implementation because the implementation of PyTorch is more efficient, faster, it's more optimized, but it's here again to just illustrate how it works. So what we have is in the numerator this exponential term e to the power of c, and then in the denominator we sum over all these exponential terms for all the activations. If we have 3 classes, it will be a sum over 3. So that's what we have here. Now let's do that. So we have our 0 z here. We have 3 classes, 1, 2, and 3, and for training examples 1, 2, 3, and 4. So these are then softmax activations that we get back. All right, now just to illustrate how we get the class label. So if you recall, I mentioned we have an argmax function. Argmax is, you can think of it, maybe I should demonstrate this. It's giving you the position of the highest value. So if I have an example, the argmax would be the highest value. So in this way, the argmax should give me 0, 1, 2, 3. The value in this case should be 3. So I put a 5 here, then this would return 0 now, because now the 0 position has the highest value. And if we have a die, it will always pick the lowest value or the lowest index, you can say. But in practice, it will be very unlikely that you have a tie here. Usually, it's very rare that you have exactly the same values because that means that weight vectors are exactly the same. Now, let's convert this to class labels. This is just to double check. So these were all true labels from the OneHot encoding. It is just to double check that this one indeed converts back to this one. And here these are our predictions. So we use the argmax to get the column with the highest probability. So we get this one, this one, and this one. And you can see there's one wrong prediction here. If we would compare those, right? 0 and 0, this is correct. 1 and 1, this is correct. Predicted class label 0 and the true label, this is incorrect. This one is correct. So we make one mistake actually. So yes, again the cross entropy. Recall that there are two sums. I kind of entangled them a little bit. So we have, this is the sum over the training examples, and this is the cross entropy for OneHot encoding. If you can't remember, do watch the previous video that I made on OneHot encoding. Then you can get a sense of what's going on here. So let's get back to this one. Let's compute the first cross entropy for each training example. So what I'm doing here is I'm computing these loss terms for each example. So here for the training examples, the losses we get is 0.96, 0.88, and 1.05 and 0.83. So that is how we would implement this. Now maybe I can just briefly show you also how that looks like. We are just taking the log of the softmax activations and then multiply it by the target. And remember, the targets are just zeros and ones. So it says zeros and ones. So I can maybe also print it. So this would be one value and the other ones should be zeros. So one value and the other ones zeros in each row. There is only one value that is not zero in each row. And then we are summing. This is the autism here. So the first row would be on 0.68, second row would be 0.88, and then 1.05. This is actually what we see here, right? So the summing is actually just selecting. It's just selecting the values here. So in PyTorch, there is a function called NLL loss, which takes the log softmax as input. So this function, the negative log likelihood loss, expects the log of the softmax values. I'm just saying that we will use them in practice. We will actually use the cross entropy in practice, but I'm trying to explain how these functions in PyTorch work. So you can see this negative log likelihood loss is the same as our cross entropy loss. Just want to clarify this. It's important to note and remember, because here we give the softmax as input and here we give the log of softmax as input. Because when I just give the softmax input, I will get wrong results. I will get some I'm emphasizing this because it's a common mistake in practice. When people implement deep neural networks, they accidentally sometimes provide the wrong inputs and then get weird results. And then the networks are not training. In practice, actually, I recommend using this cross entropy function over the negative log likelihood function. This is numerically more stable. So if you train a deep neural network, the gradients and everything will be more stable. If you use that one, mathematically everything would be equivalent. If we use negative log likelihood loss or cross entropy in PyTorch, but stability wise on the computer, the cross entropy is more stable. So and also for this one, really pay attention to this one. It's taking the logics as input, so it's taking our net inputs as inputs, which is the logics. So here again, this is our net input matrix. When we compute the cross entropy, because we use the mathematical formulas, we compute first the softmax, and then from the softmax we compute the cross entropy in PyTorch. They do all that work for us inside this function. They do it for us. So here we give it the net inputs, and you can see our function takes the softmax. It gets the same results as these other functions, so they should be identical. But in practice, this is more stable, as I mentioned before. So I recommend using this one. And notice that I said reduction to none, which means it does not apply the sum or the average, which is the outer one here. So by default, when you use this cross entropy, it will perform the average. You can test it and see it's the same value. So this is like a code example of how all these types of losses in PyTorch work. I recommend you just play around with that. When we implement softmax regression in a later video, I will use this function, and also when we use later on multi-layer perceptrons and also convolutional neural networks, we will be using the same function. I hope this was helpful. If you have any questions, leave them in the comment box below. See you in the next video.